S3 famously talks about how it provides 11 nines durability. That's extraordinary. It's like 100 billion years, right? That's just 11 nines. So you'd expect that your, picture that you stuck into S3 is going to last for at least 50 billion years on average, right? Now, the problem with that, as you may be aware, is that the sun is going to envelop the Earth in about 5 to 7 billion years. I don't think US East 2 is going to survive that event. So, there's this basic mindset that's a bit off there. Now, they might say that, hey, it's not about, like how long your thing's going to last. It's about the probability that something is going to fail within a year, which is true, and that's reasonable. It does imply that they've never lost a piece of data. I don't know whether that's true or not. I assume it's true. They're certainly one of the best, most impressive organizations that I know of when it comes to this stuff. But the problem is that 11 nines, it comes out of the fact that they have a bundle encoding where they do something like 33 copies of data with 11 copies in each of 3 data centers. And they can therefore tolerate 11 failures. And if you figure each failure is going to happen once a year on an individual disk drive, then you basically, if it were uncorrelated, you could get to 11 nines, right? Each, you need to stack them up 1 times the second times the third, out to 11. And that gives you 11 nines. The problem is it's just not true. Now, because data centers fail, right? Your probability of losing an entire data center, let's say due to a fire or due to a blizzard which caves in the roof and so forth, it's not an 11 nines event, right? Even thermonuclear war isn't in some sense, right? And so there's a challenge in how you think about this. So I would say that, leaving aside 11 nines, which may be just a marketing thing, the question is you have to think about what things are correlated. When I was designing Aurora, most other systems had 2 out of 3 copies of data. We ended up doing 4 out of 6 in the same, 3 data centers. So 2 copies in each of the data centers. So why is that? I did that because I was looking at my largest likely correlated failure, which would be a data center, right? This is more from an availability perspective, not durability. But I was thinking about the largest possible correlated failure, 1 data center, 1 AZ availability zone. And when that one goes down, every single one of my databases is going to get 2 failures, right? For that duration of time. Now, some subset of them are going to have another failure somewhere else, just because it takes me time to repair. And so if I'm running 2 out of 3, that means I get to 1 out of 3 after that. And that means that I can't trust that whether that copy is up to date or not, which means that my database is corrupt. If I'm doing 4 out of 6, I get down to 3 out of 6, which means I can still read it and do the repair. And so that's the basic change. So I went through that fast, maybe too fast, but you get the basic idea. What you need to think about is the largest probable correlated event and associated with the independent events that could be already going on. Multiply that by the number of such things going on in your environment, and then and then divided by the duration over which that's going to happen. So, for example, if I can repair a segment inside my in an Aurora slab by within, let's say, 10 seconds, I'm basically looking for that 10-second period for the independent failures against the correlated failure that's happening against all of them. So you want to bring that number down as far as you can, that in an economically reasonable way. So for us, that ended up being 4 out of 6. Might be different for you, but I'm advising you think about is what are your correlated events? What are the ones that have ripple of downstream impacts? What is your time to repair? And what is the breadth of the thing that is being applied to? Because that obviously makes the likelihood of a failure somewhere in your environment more likely. So hopefully you can take something away from that.